first look at the world's highest performance quadrupole ICPMS, the Agilent 7700 series. The 7700 redefines ICPMS by combining high performance and flexibility with the most comprehensive automation tools, making the 7700 series the easiest to use ICPMS for
Let's follow the journey a sample takes from its sample vial through the ICPMS to the detector. Sample is pumped from the sample vial into the nebulizer, where it is mixed with argon gas to form an aerosol. Larger droplets are removed from the sample aerosol as it passes through the cooled spray chamber, and the fine aerosol is swept into the central channel of the plasma. As they travel through the high-temperature argon plasma, the aerosol droplets are dried, decomposed, atomized, and finally ionized, producing a rich source of positively charged ions. The ions are extracted from the plasma into the interface through the sampling orifice, and then through the skimmer cone into the high-vacuum region containing the ion lenses and mass analyzer. Electrostatic lenses focus the ion beam and separate the positive ions from the unwanted neutral species by bending them into the reaction cell, the heart of the octopole reaction system, or ORS. The ORS is unique in using an octopole ion guide in the cell rather than the hexapoles and quadrupoles used in other cell ICPMS systems. Octopoles are small, reducing the size of the cell and allowing operation at higher pressure relative to other systems. This results in more ion-gas collisions and greater interference removal efficiency, which also enables the ORS to operate in collision mode using pure helium collision gas. The larger polyatomic interferences collide more often with the helium atoms than the analyte ions and lose more kinetic energy. A potential barrier at the cell exit allows only the higher energy analyte ions to pass through to the mass analyzer. The low energy polyatomic ions are prevented from leaving the cell by energy discrimination. The analyte ions leaving the ORS cell enter the quadrupole mass filter and are separated based on their mass to charge ratio. Only the target ion is stable and passes along the axis of the quadrupole. The quadrupole scans rapidly across the mass range and passes each mass of interest sequentially to the electron multiplier detector. Ions strike the detector, and the resulting electronic signals are processed by the detector electronics and stored in a multi-channel scaler, creating a mass spectrum where intensity at a given mass is proportional to
ICPMS are low detection limits. So the ICPMS can detect low concentration analytes, has a high degree of selectivity, so it has a great ability to respond to specific constituents, and it has good accuracy and precision. And for sample introduction, you have your nebulizers, which are produce your liquid samples as an aerosol, and your solid sample introduction, which is your laser ablation, which is more common in solid.